Okay, so for the clinometer project, we have this tool called the clinometer. And this clinometer has a protractor with a straw here, and then we have a string with a weight on it. And what you do is you look through the straw at an object. So say I'm trying to find the height of the ceiling. I'm gonna look through the straw at the ceiling, and this string dangles onto the protractor to let me know that I am looking up at about we'll say that's like a 23-degree angle right there. So when I'm using this to calculate the height of a given object, the angle that is being formed is not from the ground, it's from my eye level. So if I were to draw an invisible line straight across, that would be 0. That's our horizontal line that our angle is being built off of, and our angle is upwards from here. So when we're trying to solve for the height of an object using the clinometer, we need to account for both the height from our eye level, but also the height from our eye level down. So I'm going to draw that out on a piece of paper to help you understand exactly what we're doing with task number 1. Before we go ahead and solve task number 1, I do want to mention that we have some fake data as if you did go out and use the clinometer to measure. So we have a flagpole, and we're saying that the eye level of the person holding the clinometer, the measurer, is 5'8", which as a decimal is 5.67 feet. And then we have all of our data from our trials here. So trial number 1, we were 20 feet away from the object, and we measured 44 degrees of our angle of elevation. For trial number 2, we had 35 degrees and a 32-degree angle. For number 3, we were 15 feet away and we measured 56 degrees. For number 4, we measured 25 feet away and it was 40 degrees. So that is the data that is being used to calculate each of these trials. So trial number 4, we have 25 and 40 degrees. Trial 3, 15 and 56 degrees. Trial 1, we have 20 and 44 degrees. Trial 2, 35 and 32 degrees. So starting with trial 1 here, I'm just going to go ahead and sketch out exactly what was happening when we were measuring with the clinometer. So I have this person here, and they are standing looking horizontally across to some flagpole. And we'll draw a flag off the end, and there's our flagpole. The clinometer is looking upwards at the top of the flagpole at a 44-degree angle of elevation. And we know that this person is 20 feet away horizontally. That is the same distance that they are on the ground away from the flagpole. When we calculate for our missing side of our triangle right here, that's only getting this piece right here. That's only measuring that height. It is not measuring the full height, which includes the height of our person over here, which we're actually gonna draw a gray line on top of that because I'm going to use gray for that piece. Alright, so to solve this, I need to think through my trigonometric functions. I have SOHCAHTOA, and I'll write that on the side over here. SOHCAHTOA, where sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So I know that I'm going to have to use this angle. I also didn't write this in here, but I do know that this is a right angle because it is a horizontal distance with a vertical line here. So we have a right angle, we have a 44-degree angle. We know that to our 44-degree angle, we have an adjacent side of 20, and we are solving for the opposite side, which is missing. So I need a function that has both the adjacent and the opposite, and the only function that does that is tangent. So I'm going to need to solve using the tangent of 44 degrees is equal to the opposite side, which is unknown, over the adjacent side, which is 20 feet. From there, you should be able to solve this out on your own. I am going to continue here. So we're going to multiply out 20 on both sides, and then write in our calculator, because this cancels out and leaves us with x, I'm going to type in, making sure I'm in degrees, which I am, although you can probably not see that. We'll move down here. So yeah, I want to be in degrees. I'm going to type in 20 times the tangent of 44 degrees, close the parentheses, hit enter. That tells me that I have, from this piece to that, from eye level up, a height of 19.31 degrees. Sorry, feet. So that means x equals 19.31. But that is not my answer. That's just the distance from eye level to the top of the flag. In order to calculate the overall height, I need to add that 19.31 to our eye level height, which is 5.67. When I add those two things together, I will get my overall height, which is what I'm trying to solve for in the first place. So 19.31 plus 5.67 gives me an overall height of 24.98. And that is what goes on this line here. Okay, once you have done that for all 4 trials with your different distances and angles of elevation, you're going to, on the second page, you have number 2, based on your calculations, give a final estimate for the height of the object. You're going to have to use the 4 answers you get to determine the actual height. One good option could be to average them. Once you have that, on this page we have a space for the object we measured, which is a flagpole. We have a space for the final estimate of its height, and let's just say that our final estimate is 24 feet. And you might get something else, but I'm just going with 24 for the purpose of this example. And our eye level was 5.67. When you're solving the rest of these questions, you're no longer solving for the height of the object. On number 3, you are solving for the angle of elevation. If you're solving for an angle, make sure you're using an inverse function, so inverse tangent would probably be what you want. Number 4, you're also solving for an angle of elevation. You need to keep in mind that when you're solving these, you're solving from eye level up. So instead of using your 24 feet, you need to subtract your eye level out so that you're only solving from the sides of the triangle, eye level up to the top of the object, not from the ground. Then with 5 and 6, number 5, you're solving for the distance from the base of the object, but you have degrees. And number 6, you're also solving for the base of the object with a 55-degree angle. On these ones, you'll also need to keep in mind what your actual height is. And you'll again need to be solving for only the side of your triangle, so you're taking your overall height of 24 feet and subtracting the height of the eye level, which is 5.67 feet. All right, hopefully this gives you a better idea of what you should be doing for this project. I would like you to go ahead and fix what you've already done and then resubmit, and then I will regrade your projects.